Welcome to the fifth and final video, which accompanies the example 2, typed written notes. This will go to actually solving the maximum deflection, the minimum deflection, and determining the constant integration for the final equation. The final deflection is going to look like that. Once we integrate that, we will have this, our equation for the deflection at from point B to point C. Now, for boundary conditions we have for this are going to be that at point B there is a roller, and thus the deflection has to be 0. So that very conveniently means that our final constant integration immediately goes to 0 because of that. So that's convenient. So when we want to know the maximum of anything, then we're going to want to look at its derivative. Now, fortunately for us, we've already got all of the derivatives of pretty much all of these functions, right? Or no, we have the derivatives of all of these functions, definitely. So if we want to know the maximum rotation, we're going to look at our two deflection functions and find if we want to know the maximum deflection, we'll take our two rotation equations and we'll find the points where they are 0, and that'll be quite easy. So for the rotation A, we can say that rotation A to B as a function of x is equal to, I'm going to move the Young's modulus and the second moment of inertia over there, because if we're looking for the maximum or the minimum deflection, it doesn't matter, because we're just going to set that equal to 0. And that's going to give us 1 kip times x cubed minus 1.5 kip over 24 feet x1 to the 4th, and then what did I say C5 was? Minus 35.4375 kip feet squared. We have to find the points where that equals 0, and that will be that's going to happen at x1 is equal to 4.3ish, 4.287 feet, which is within the bounds of x1. x1 goes from 0 to 9 feet, so that's going to be where our local minima is. The local maximum is there isn't going to be one that we find in this way, but if we do plot the deflection, you'll find that it makes a shape. Bows down right here. Its minimum is at 4.3ish. It hits 0 again at B because it's gotta. And then it's going to start slowing down its slope a little bit, but it is going to just be levering up C. So our maximum is going to be just pop in 3 feet to this integration, or this function, and see what we get for that. Alright, that is it. I hope you enjoyed hearing my neighbor moving his furniture.